AI is amazing, but it knows nothing about your data. ChatGPT can write poetry, explain quantum physics, and code entire applications. But ask about your company policies, your research papers, or your personal notes, and it has no clue. Today, we're solving this problem by building a RAG chatbot that turns any PDF into instant AI knowledge. But before we start coding, let's first understand what RAG actually is and why it's important. Imagine you're building a chatbot for your company, maybe an internal tool where employees can ask questions about company policies, benefits, or procedures. Now, the problem is that AI models have never seen your company's data. They don't know your vacation policy, your expense reimbursement process, or any of your internal information. So with a traditional chatbot, when someone asks, what's our vacation policy, or how many sick days do I get, the AI can't answer because it simply doesn't have that information. That's where RAG comes in. RAG stands for Retrieval-Augmented Generation. Retrieval means we search for and retrieve relevant information from your own data sources. Augmented means we enhance the AI's capabilities by providing this retrieved information. Generation means the AI generates a response based on both its training and the information we provided. Instead of the AI trying to remember everything, we give it access to your company's knowledge base. When someone asks a question, we quickly find the relevant documents, hand them to the AI, and then the AI uses those documents to generate an accurate answer. The really cool part is that this works instantly with any updates. If you changed the vacation policy last week, or if you added a new benefits package, it is immediately available. The AI becomes a knowledge assistant that has access to all your current documentation. So that is what we're building today, a RAG chatbot. By the end of this tutorial, you'll have built a RAG application with real-time streaming chat interface, PDF upload and processing, vector embeddings for semantic search, beautiful UI with Chatbot and AI elements, user authentication and role-based access control with Clerk, and production-ready database with Neon. Whether you're building an internal tool for your team, a customer support chatbot, or just learning to build AI applications, this tutorial will give you a solid foundation in modern RAG architecture. And to understand the project to its fullest, please make sure to watch the Next.js AI SDK playlist on the channel. Let's start building. First, create a new Next.js project. In the terminal, run the command npx create next app at latest, and we want to create the project in the current directory. When prompted, select yes for TypeScript, biome as your linter, Tailwind CSS, yes to source directory, yes to app router, turbopack, and no to import alias. When the command completes, you will have a new Next.js app ready to go. Run the app with npm run dev, and in the browser, open localhost 3000. You should see the Next.js welcome page. Now that we have our Next.js app set up, let's build a standard AI chatbot. The user will enter a prompt. We will send it to a route handler that interfaces with OpenAI and stream the response back to the UI. Back in VS Code, let's install the AI SDK packages we need. npm install AI at AI SDK/OpenAI at AI SDK/React and Zod. AI is the core AI SDK package. AI SDK/OpenAI connects us to OpenAI's models. AI SDK/React contains React hooks for building chat interfaces. And Zod helps us create type-safe schemas. Next, let's set up the UI components. We'll use Chatbot UI and AI elements. In the terminal, run the command npx Chatbot at latest space init. Select neutral, and then run the command npx Chatbot at latest space add. We'll keep this simple and select all the components. Press A to select all and press enter. Next, we'll add AI elements. The command is npx AI-elements at latest. This gives us pre-built components specifically for AI applications. If we expand the source folder, components folder, we can see Shalcyan components in the UI folder and our AI-specific components in the AI elements folder. Now, before we write any code, we need to add our OpenAI API key. In the project root, create a .env.local file. Add a new variable called OpenAI _API key and add your actual OpenAI API key. I'm going to do this behind the scenes. Now let's create the chat route handler. In the app folder, create a new folder called API. Within this folder, create a new folder called chat with a route.ts file. Start with a basic post handler. Export async function post receives request of type request and empty curly braces. Next, let's add our imports at the top of the file. Import the stream text function from the core AI package and the OpenAI provider from AI SDK/OpenAI package. These work together to stream text using OpenAI's models. We will also import the UI message type and convert to model messages helper function from the AI package. Within the post function, let's get the messages from the request. Await request.json. This returns an object from which we destructure messages. The type of messages is UI message array. Next, let's call stream text to generate the response. Const result is equal to stream text. We pass in an object with model set to OpenAI, GPT 4.1 mini, and messages set to convert to model messages, passing in messages. We use the helper function to convert the messages from the UI to the format expected by the model. Now, I'm using GPT 4.1 mini for this tutorial, but if you want to use GPT 5 mini, there is an extra step you need to take if your organization has zero data retention policy. But I'll keep it simple and use GPT 4.1 mini, so I recommend you do the same to follow along. Once we have the result, let's return the streaming response. So return result.toUI message stream response. Let's also add error handling with the try-catch block. So try, closing curly braces, catch. You get hold of the error, console.error, error, streaming chat completion, and log the error. And we return a new response, failed to stream, chat completion, status 500. Perfect, our route handler is complete. Now let's build the UI. In the app folder, create a new folder called chat with the page.tsx file. Here, define a basic React component. Export default function, rag chatbot, and we return a div tag. This component will be a client component since we'll need interactivity. So add the useClient directive at the top of the file. Now the AI elements package gives us beautiful components for chat interfaces. Let's import a couple of them. To save us some time, I'm going to paste the imports here. You can copy these from the GitHub repo linked in the description, but also feel free to style the UI to your liking. You can take a look at the AI elements docs for detailed information on each component. But the first set here is related to prompt input and submission. The second set here related to rendering the conversation. And loader is basically a loading indicator. Now that we have the components imported, let's start building the JSX structure. First, we'll create a container that centers everything and takes the full height. So div class name is equal to max width 4XL, MX auto, padding 6, relative, size full, and the height for now is going to be the 100% of viewport height. So calculate 100 VH. Within this div tag, we're going to nest another div tag. This one with class name is equal to flex column to vertically place our items, and full height. Now let's add the conversation component. So conversation, class name is equal to full height, And within the conversation component, we're going to nest conversation content, and this is where our messages will go. And then a conversation scroll button component. The conversation component handles the scrollable area, and the conversation scroll button adds a nice button to scroll to the bottom. Below the conversation, we will add the prompt input. So prompt input will add some top margin, and we will nest a couple of components. First, prompt input body. This will contain the prompt input text area, and below the text area, prompt input toolbar with the submit button. Optionally, you can also include prompt input tools for elements like a model selector, the web search icon, extended thinking, and so on. We will not implement this for our chatbot, but I will leave a placeholder here for you to understand where the additional functionality can go. There is a type error on prompt input, but we will fix this in a bit. But we now have the structure in place. Of course, nothing works because we haven't connected it to any logic. So let's add state for the input field. Import useState from React, and we will also import the fragment component, which we will need for rendering messages in a bit. Within the component, let's add the state. So useState, the variable is called input, the setter function set input, and the initial value is an empty string. We will bind this to prompt input text area. So value is equal to input, and onChange is equal to an arrow function which receives the event, and we call set input event.target.value. Next, for managing the chat state, we will use the useChat hook from AI SDK/React package. Import it at the top. Invoke the hook within the component. Use chat. This hook gives us an object from which we can destructure messages, which is the conversation history, send message, which is a function to send new messages to the API route, and status to know status of the chat. By default, this hook automatically connects to /API/chat, which is exactly what we have created. So please make sure to follow the same route structure. Now let's render the messages. Inside conversation content, curly braces, messages.map, pass in a callback function. For each message, render a div tag with key is equal to message.id, and each message has parts, allowing the messages array to contain different types of content. Let's map through the parts. Curly braces, message.parts.map. We pass in a callback function. We get access to the individual part as well as the index. And within the function body, we will use a switch statement to handle the text part type, which is the only part type we'll have for this implementation. So switch statement on part.type, curly braces, and for case text, we return React fragment with key set to $curly braces, message.id, followed by the index to make sure this is unique. We will then invoke the message component with from set to message.role. And this prop tells the message component whether this is from the user or assistant. The text will get styled appropriately. Within the message, we render message content with the response component rendering part.text. The response component handles the markdown rendering. We'll also add a default case where we return null. Next, let's use the status enum and add a loading indicator that shows while we're waiting for a response. So right before ending conversation content, curly braces, if status is equal to submitted or status is equal to streaming, render the loader. Finally, we'll add a handler that calls send message for when the user submits a message. Const handle submit is a function receives message of type prompt input message, and within the function body, if there is no text, so if there's no message.text, we don't send anything, we simply return. Otherwise, we send the message passing in an object with text set to message.text and clear the input. So set input, empty string. This message, by the way, is automatically passed as an argument to handle submit when we assign it to the onSubmit prompt of the prompt input component. So on prompt input, onSubmit is equal to handle submit. Our TypeScript error is also fixed. Perfect. Our UI is now complete. Time to test our standard AI chatbot. Navigate to localhost 3000/chat, and you should see the clean chat interface. Enter the prompt, what is React, and submit. The AI will stream back a response. Try a follow-up like, can you give me a code example? And the chat maintains context and provides a relevant example. But now, watch what happens when you ask, what is our company's vacation policy? The AI can't help because it doesn't have access to that information. But before you give AI access to internal information, you would want to control who has access. For this next section, let's add authentication with Clerk, our sponsor for this video. Clerk gives us a complete authentication solution with pre-built UI components and user management. Click on the link in the description to follow along. First, sign up to create an account if you haven't already. I'm going to enter my email and password. Verify your email, and now, once you're logged in, create a new application. Enter the name of the application as AI Chatbot. Select sign-in options that you want to support, and you can see a preview of the UI on the right. With the default options, we will have email, password, and Google Authentication. I will also add GitHub. You can see the same updated in the preview. When you're happy, click on the Create Application button. This brings us to the instructions page. Choose Next.js as a framework if it's not already selected. Now, let's follow the steps together to add Clerk to our project. Step 1. Install the Clerk package. Copy the command from the Setup Instructions page and run it in your terminal. Step 2. Set up your Clerk API keys. Copy the publishable key and secret key from the Setup Instructions page and add them to your .env.local file. I just completed that step behind the scenes, but make sure to use your own keys instead of mine. Step 3. Create a middleware.ts file in the source folder. So within the source folder, new file, middleware.ts. Copy the code from the Setup Instructions page and paste it in the file. This will help us access auth data and configure protected routes later. Step 4. Wrap your entire application with the Clerk provider component, which is a React component that provides Clerk's context to your application. We will do this a little differently to what the setup instructions show. In the root layout file, so layout.tsx, import Clerk provider component at the top from @clerk/Next.js and wrap the JSX with it. So return Clerk provider. All right, now that we have Clerk set up, let's add sign-in and sign-out functionality to our application. Inside the components folder, create a new file called navigation.tsx. We will define and export a React component called navigation. So export const navigation is equal to an arrow function. Now, the great thing about Clerk is that it provides pre-built components that handle all the authentication flows for us. We will import the sign-in button, the sign-out button, the sign-up button, the signed-in component, and the signed-out component from Clerk. We will also import the button component from Chatbot UI. For the JSX, we will start with the nav element with a border and a flex container nested inside it. Within the container, we'll add a logo of sorts. So a div tag. Let's call this rag chatbot with class name TextXL, font semi-bold. We will also add a div for the sign in and sign out buttons, a flex class to place the buttons side by side, and gap2 for some spacing. Now within the div, let's use the Clerk components. The signed out component renders the children when the user is not signed in. In that case, we will render the sign in button and sign up button components using the Shatsian button component. So sign in button with Shatsian button. The text is sign in. Variant is equal to ghost. And we will also add mode is equal to modal to open a modal dialog instead of redirecting to a separate page. Right next to the sign in button, we will add the sign up button. Mode is equal to modal. We will use Shatsian button component once again, and the text is sign up. Along similar lines, we invoke the signed in component, which renders the children when the user is signed in. So in that case, we will render the sign out button component using the Shatsian button element. Sign out button, the Shatsian button component with the text sign out, and variant is equal to outline. Our navigation is ready. Include this in your layout.tsx file. Within the body tag, import and invoke the navigation component. Import it at the top from components/navigation. To accommodate for the navigation, in page.tsx, we're going to remove some height from the page. Check the browser, and we see the navbar with the logo top left and the sign in and sign out buttons top right. Let's test if the auth flow works as expected. Click on the sign up button and create an account with your email and password. Verify your email, and once signed up, you should be redirected back to the home page. We now see the sign out button instead of sign in or sign up. Click on the sign out button, and you're logged out. Redirected to the home page. Click sign in, enter your email and password, and you should be redirected back to the home page. Perfect. Our auth setup works as expected. For the next step, let's protect our chat route so only authenticated users can access it. Right now, anyone can go to /chat, which is not great for internal information. So let's add this protection logic in the middleware.ts file. First, we'll import a function called createRouteMatcher from Clerk, which helps us define which routes are public. So const isPublicRoute is equal to createRouteMatcher. We pass in an array, the root route, along with sign in and sign up. We're saying that the home page and auth pages are public. Everything else needs authentication. Next, we'll pass a function to Clerk middleware. This is an async function, which receives the auth object and the request object as arguments. In the function, we check if the request does not match any of the public routes. So if not isPublicRoute, passing in request, and if that is the case, we call the protect method on the auth object. So await auth.protect. This method will redirect the user to the sign-in page automatically if they're not signed in. You can see how easy it is to implement route protection. Let's test if it works as expected. Sign out and navigate to localhost 3000/chat. You should be redirected to the sign-in page. Sign in with your email and password. And once signed in, you should be automatically redirected back to the chat page. Our soon-to-be internal RAG chatbot is now protected, and only authenticated users can access it. For the next step, let's add the ability to upload knowledge documents that our chatbot can use to answer questions. This feature involves 3 separate parts that all work together. First, we need a UI where users can upload documents. We will keep it simple and stick to PDF documents for this project. Second, we need a server action that processes these PDFs. The server action will extract the text from the uploaded PDF, chunk it into smaller pieces, and then convert those chunks into vector embeddings using OpenAI's embedding model. Chunking helps improve the accuracy and efficiency of semantic search and is a crucial step in RAG. Third, we need to store the vector embeddings in a vector database. This becomes our knowledge base that we will search against when users ask questions in the chat. Let's start with the database setup first, as we need a place to store the embeddings before we can process any PDFs. For our vector database, we will use Neon. Neon is a serverless Postgres database that supports vector operations, perfect for storing our embeddings. Head over to neon.com and create an account. Once you're logged in, let's create a new project. Name it RAG Chatbot. For the Postgres version, select 17, choose AWS as the provider, and pick a region close to you. Then click Create Project. Once the project is created, you will see a Connect to your database card. Click Connect and click the Copy Snippet button to copy the connection string. Now let's add this to our .env.local file. Neon _database _URL and paste the string without the PSQL prefix. All right, that's all we need from the Neon console. Everything else we'll do with code. So let's install the packages we need. In the terminal, run the command npm install at neon database /serverless drizzle-kit and .env. Neon database /serverless is Neon's database driver for TypeScript. Drizzle ORM is a type-safe ORM that lets us write TypeScript instead of SQL to work with our database. Drizzle-kit is the CLI tool we'll use for handling database migrations or changes. And .env helps us load environment variables. All right, now let's set up our database connection. Inside the lib folder, create a new file db-config.ts. First, we'll import the functions we need. Import Drizzle from Drizzle ORM /neon HTTP, which creates our database instance, and also import Neon from Neon database /serverless to create the connection. We'll also import config from .env to load our environment variables. Now let's make use of the imports. First, call config, passing in an object with path set to .env.local. We're basically loading the environment variables from our .env.local file. Next, create a SQL client with our connection string. So const SQL is equal to neon process.env.neon database URL. And we use the exclamation to let TypeScript know we know what we are doing. Finally, wrap SQL with Drizzle. So export const db is equal to Drizzle SQL. Our database connection is now ready. Next, let's define our database schema. In the same lib folder, create a new file called dbschema.ts. First, import the types we need from Drizzle: pgtable, serial, text, and vector. Now let's define our documents table. Export const documents is equal to pgtable. We'll call it documents. We'll have ID of type serial ID, and this is primary key. We'll have our content, which is text, and this cannot be null. Finally, we'll have our embedding. This is of type vector, and we specify dimensions 1536. So the ID is an auto-incrementing primary key. The content field stores the actual text chunk from your PDF document. And embedding is a vector field with 1536 dimensions, which is the size of OpenAI's text embedding 3 small model output. But searching through vectors can be slow if you don't have an index. So let's add one. Import index. And as a third argument to pgtable, specify a function which returns an array. The function gets access to table, and we call index. Let's name this embedding index dot using hnsw table dot embedding dot op vector cosine ops. If this is confusing, don't worry too much about it. It's just syntax you have to follow. This basically creates an HNSW index, which stands for Hierarchical Navigable Small World, and it's an algorithm that makes similarity searches really fast. Now let's also export types for TypeScript. So export type insert document is equal to type of documents dot $infer insert. And similarly, export type select document type of documents dot $infer select. Our schema is ready. The next step is to configure Drizzle. In the root of your project, create a drizzle.config.ts file. Here, import config from .env and define config from DrizzleKit. Next, load the environment variables. So config path.env.local, and then export default define config, pass in an object. We set schema to /source lib dbschema.ts out to /migrations dialect Postgres and db credentials URL process.env neon database URL with exclamation. So this tells Drizzle where our schema is, where to put migrations, and how to connect to the database. Now here is an important step. Neon's Postgres needs the PG vector extension to work with vectors. So first, let's create a custom migration to enable it. In the terminal, run the command npx drizzlekit generate -- custom. This creates a new migration file in the migrations folder. Open that file and add create extension if not exists vector. Now run the migration to enable the extension npx drizzle-kit space migrate. Our command completes, and now let's verify if it worked. Go to your Neon console, open the SQL editor, and run select extension name, extension version from pg_extension, where extension name is equal to vector. You should see the vector extension listed with the version number. Now we can generate the migration for our documents table. Run the command npx drizzlekit generate. This will create a new migration file in the migrations folder. We can see the SQL, create table documents, ID content embedding, and an index. Now you can run npx drizzlekit migrate. Our command completes, and to verify everything worked, back in Neon console, click on tables, and you should see the documents table. We have ID, content, and embedding, which is vector of 1536 dimensions. Perfect. Our vector database is now ready. We have a place to store our document chunks and their corresponding embeddings, and we have set the HNSW index to support fast similarity search. The next step is to create our server action for uploading documents. But before we build that server action, we need a couple of utility functions it will use. First, we need utility functions for generating embeddings. When we process a PDF, we'll need to generate embeddings for multiple chunks of text. And later, when a user searches, we'll need to generate an embedding for their search query. Let's create both. Back in VS Code, create a new file in the lib folder called embeddings.ts. Begin by importing the embed function from the AI SDK and the OpenAI provider. Now let's start with the single embedding function, which we will use for search queries. Export async function generate embedding. This takes a string and returns an array of numbers, which is the embedding vector. Inside the function, we'll clean up the text. So const input is equal to text.replace new line character with an empty space. And then we'll generate the embedding. Await embed. We pass in an object. Model is set to OpenAI.text embedding model. And we use text embedding 3 small, which produces 1536 dimensional vectors, exactly what we configured in our database schema. We will also pass input as the value. This returns an object from which we can destructure the embedding. We return that embedding. Now, for processing PDFs, we'll have multiple chunks to embed. We could call generate embedding for each chunk, but that means multiple API calls, which is slow and expensive. Instead, let's create a batch function. Import embed many from AI SDK and create the batch function. Export async function, generate embeddings, plural. This gets texts, which is an array of string. And within the function body, const inputs is equal to texts.map. And for each text, we replace new line with a blank space. And then we call embed many with the same model. So OpenAI text embedding model. And values, plural, is going to be inputs, plural. This returns an array of embeddings, which we can destructure. Finally, return embeddings from the function. Perfect. We now have utilities for generating embeddings, singular for search queries and batch for document processing. Next, let's create the chunking utility. Remember, we need to break PDFs into smaller pieces so we can retrieve just the relevant sections when users ask questions. We'll use a package called LangChain that has utilities specifically for text splitting. Back in VS Code, run the command npm install @langchain/textsplitters. Now create a new file in the lib folder called chunking.ts. Chunking.ts. First, import a function called recursive character text splitter from @langchain/textsplitters. Then invoke the function. Export const text splitter is equal to new recursive character text splitter. We pass in an object, chunk size set to 150, and chunk overlap set to 20. Chunk size 150 means each chunk of text will be roughly 150 characters. That is pretty small, but for this demo, it works well. In production, you might use 500 or 1000 characters. Chunk overlap 20 means consecutive chunks will share 20 characters at their boundaries. This helps us maintain context across chunks and is very important. And let's add one more parameter to make the splitting cleaner. Separators is an array, and we specify just one, which is a single space. This prevents words from being cut in half. Now let's create the function that uses this splitter. So export async function, chunk content, receives content of type string, which will be the PDF content in our case. And we call the split text method textSplitter.splitText and pass in the content. We'll trim the content to remove any leading or trailing white space. So content.trim. The function will return an array of strings, and each string is a chunk. So return await textSplitter.splitText. That's it. Our chunking utility is now ready. It takes a long piece of text and breaks it into smaller overlapping chunks that are perfect for embedding and searching. We have both the utilities our server action needs: embedding generation and text chunking. Now let's build the server action that brings everything together. We'll extract text from PDFs, chunk it, and generate embeddings and store everything in our database. First, we need a package to extract text from PDFs. So in the terminal, run the command npm install pdf-parse. We need to treat pdf parse as external in the server build. So update next.config.ts to include it. The configuration is server external packages, and we specify pdf parse. Next, create a new folder in the app directory called upload, and inside create a file actions.ts. Add the use server directive at the top of the file. This tells Next.js this is a server action, which is code that runs on the server but can be called directly from client components. Now let's import what we need. We import the PDF parser, so PDF from PDF parse, our database connection, so import db from lib/dbconfig, the documents table schema, and the two utilities we just created, generate embeddings, plural, and chunk content. Now we have an error for PDF parse because we haven't installed the types. So run the command npm install at types/pdf-parse. Perfect. Now let's create the function that processes PDFs. Export async function, process PDF file, and this function receives form data from the upload form data of type form data. Now, form data is how browsers send files to servers. Within the function body, let's extract the PDF file. We'll start with a try-catch block for catching any errors. So console.error, PDF, processing error, logging the error, and we return an object with success set to false and error set to failed to process PDF. Within the try block, we get the file from form data. So const file is equal to formdata.get PDF as file. Now to extract text from the PDF, we need to convert the file to a buffer and then pass it to PDF parse. So const bytes is equal to await file.arrayBuffer, and then const buffer is equal to buffer.from bytes, and finally const data is equal to await PDF buffer. So first we convert the file to an array buffer, then to a Node.js buffer, then pass it to PDF parse, which extracts the text. Next, let's check if we actually got any text. So if there's no data.text or data.text.trim.length is equal to 0, we return success false and error no text found in PDF. So if the PDF is empty or has only images, we return an error. But if it does contain text, let's use our chunking utility. So const chunks is equal to await chunk content, and we pass in data.text. This breaks the entire PDF text into smaller chunks. Next, generate embeddings for all the chunks. So const embeddings is equal to await generate embeddings, and we pass in chunks. We use our batch function to generate all embeddings in one API call. Now let's prepare the data for our database. So const records is equal to chunks.map. We pass in a callback function. We get access to individual chunk as well as the index, and we return an object where content is set to chunk and embedding is set to embeddings of index. So we create an array of records where each record has the text chunk and its corresponding embedding. The chunks and embeddings are in the same order, so we use the index to match them up. Finally, insert all records into the database. Await db.insert documents, and the values we insert are the records. We then return an object where success is set to true and message is set to created records.length searchable chunks. All right, our server action is complete. It handles the entire flow from receiving a PDF file to storing searchable chunks in a vector database. Now, let's build the UI where users can upload PDFs. This will call the server action we just created. In the upload folder we created earlier, add a page.tsx file. Let's define a basic React component. Export default function, PDF upload, and we return a div tag. This is a client component since we'll need to handle file uploads and show loading states. So add the useClient directive at the top. Next, let's import what we need. We need useState for managing component state and our server action. So import process PDF file from /actions. Now let's import the UI components we need. Card and card content, label, input, alerts, and loader. These are ShadCN UI components we'll use for the UI. Next, let's set up the state we need. Inside the component, invoke useState. The variable is isLoading. The setter function setIsLoading, and the initial value is false. We will also track any messages to show the user. So useState, messages, set messages, and the initial value is null. The type, however, is an object where we have type property that is either error or success, and text property a string. It is either this object or null. Now let's build the JSX structure. Start with the container. So a div tag with class min height screen, background gray, 50, some vertical padding and horizontal padding. Next, another div tag with class name max width 4XL and MX auto. Next, add the page title. So H1 PDF upload. We'll also add some Tailwind classes for styling. Text 3XL, font bold, text gray, 900, margin bottom 8, text center. Now add the upload card. So invoke the card component from ShadCN with class name, margin bottom 6. Invoke the card content component inside with class name, padding top 6. And we'll add a div with class space y4. This will add some spacing between the label and the input, which we will define now. So invoke the label component. The label is upload PDF file. We will add HTML4 is equal to PDF-upload. And below the label, the input component, ID is equal to PDF-upload. Type is equal to file. We set accept is equal to .pdf to only allow PDF files. On change is equal to handle file upload, which we will define in a moment. Disabled is equal to isLoading, and some more top margin. Below the input, add the loading indicator. So curly braces, isLoading, and render a div tag with class name, flex, item center, gap2, loader2, with class name is equal to height 5, width 5, animate spin, and span tag that says processing PDF. We will also add some styles. Text muted, foreground. This shows a spinning icon and message while processing. The loading should actually be outside the div tag. Finally, add the message display. So braces, message, and if that exists, we render the alert component. We nest the alert title and the alert description. We have cannot find message. The state variable should be message and not messages. So message and set message. Back in the JSX, for alert, we're going to specify variant is equal to if message.type is equal to error, destructive, otherwise default. For the alert title, if the message type is error, we render the text error, otherwise we render the text success. And for the alert description, we render message.text. So the alert shows success or error messages. The variant changes the styling based on the message type. Now let's create the file upload handler that the input calls on change. Const handle file upload is equal to an async function. It receives event of type react.changeEvent HTML input element, and within the function body, we get the selected file. So const file is equal to e.target.files, and if that exists, the first file. And if there is no file, we simply return. Set isLoading to true and set message to null to clear any previous messages. Now let's call our server action. We'll add a try block with catch, and if there is an error, we set message, passing in an object where we set type to error and text. An error occurred while processing the PDF. We will also add a finally block where we set isLoading to false. In the try block, however, we create form data. So const form data is equal to new form data, and we append the file. So form data dot append the file with the key PDF. This is what our server action expects. So call the server action process PDF file, passing in the form data, and handle the result. Const result. Successful, so result dot success. Make sure to await the server action. So if result dot success, call set message, passing in type success and text set to result dot message. And if that doesn't exist, PDF processed successfully. We will also set e.target.value is equal to an empty string. So we are clearing the file input. If the result is not successful from the server action, we call set message, we set type to error, and text result.error or failed to process PDF. And that is our PDF upload UI. Let's test this. In the browser, navigate to localhost 3000/upload. You should see the upload interface. Try uploading a PDF file. I'm going to upload this Tech Corp Solutions Employee Handbook, which is a PDF file I had generated from AI. It has a few sections like health and wellness benefits, professional development, code of conduct, performance reviews, expense reimbursement policy, and communication guidelines. You can upload any PDF you want to. So upload, and you will see a loading spinner, then a success message telling you how many chunks were created. Success created 28 searchable chunks. If you take a look at Neon and refresh the documents table, you will see the chunks are now stored in your vector database with their embeddings ready to be searched. We have content and the corresponding embedding. And for each chunk, if I were to open the third one, for example, you can see we start with balance while delivering and end with through innovative technology. If I go to the previous one, you can see the overlap balance while and the one after technology. Our PDF upload works as expected. We can now process PDFs, extract their text, chunk them, generate embeddings, and store everything in our vector database. Next, we need to implement semantic search so our chatbot can find relevant chunks when users ask questions. Back in VS Code, we'll create a search function that finds similar documents based on meaning. So create a new file in the lib folder called search.ts. Here, we will import several functions from Drizzle. So import from Drizzle ORM. Cosine distance calculates how similar or dissimilar two vectors are. DESE sorts in descending order. GT means greater than. And SQL lets us write raw SQL expressions when needed. We will also import our database connection. So import DB from dbconfig, our schema, so documents from db schema, and the single embedding function we created earlier. So import generate embedding singular from /embeddings. Next, let's create the search function. Export async function, search documents, and the function takes 3 parameters. Query of type string, which is what the user is searching for. Limit of type number with a default value of 5, which controls how many results to return. And threshold of type number with a default value of 0.5, which dictates the minimum similarity score. We will ignore results below 0.5 similarity by default. This should be number. Now within the function body, first, we need to convert the search query into an embedding. So const embedding is equal to await generate embedding, and we pass in the query. Next, we need to calculate similarity between this query embedding and all the document embeddings in our database. Drizzle's vector support helps us with this. So const similarity is equal to, we calculate the cosine distance between the query embedding and all the document embeddings in our database. So cosine distance, documents.embedding as the first argument, and query embedding as the second argument. But cosine distance measures the dissimilarity between two vectors. So we will subtract from 1 to get the similarity. We will use SQL number template literal 1 minus $curly braces cosine distance. Now let's build the database query to get the most relevant documents. So const similar documents is equal to await db.select. We will select the document ID. That is going to be documents.id. The content is going to be documents.content. And we will also select the calculated similarity score. And we do this from our documents table. We will then add the threshold filter. So .where we call greater than, passing in similarity and threshold. We only want documents with similarity above 0.5, which is the default threshold. Finally, we will sort by similarity and limit the results. So order by descending of similarity, and we limit to limit, which is 5 by default. We will return similar documents from the function. This function is the heart of our RAG system. It takes a natural language query, converts it to an embedding, searches our vector database for similar chunks, and returns the most relevant ones. The index we created earlier makes this search fast even with thousands of documents. And because we're using cosine similarity, it finds documents based on meaning, not just matching keywords. Now we have all the pieces. We can upload documents, search them, and chat with AI. Let's connect everything together so our chatbot can actually use the knowledge base when answering questions. Currently, our route handler just streams responses without any access to our documents. Let's give the AI a tool it can use to search the knowledge base. In the route handler present in the chat folder, first add tool to the list of imports. From the AI package, import tool. This lets us define tools the AI can use. We will also need Zod for the tool's input schema. So import Z from Zod. We will also import the search function we just created. So import search documents from lib/search. Now let's define a tool for searching the knowledge base. Before the post handler, const tools is equal to an object. The tool name is search knowledge base, and we invoke the tool function we just imported. We pass in an object with description, search the knowledge base for relevant information. We'll define the input schema, which is z.object. It has a query property, which is z.string, and we describe it as the search query to find relevant documents. And then execute is an async function. This gets access to query. So the AI will use the description to know when to use this tool, and the input schema tells it what parameters to provide. Let's implement the execute function. We'll add a try-catch block where we console.error, search error, followed by the error, and we return a string, error, searching the knowledge base. And within the try block, const results is equal to await search documents, passing in the user's query. We limit to 3 relevant documents and 0.5 as the threshold, which is also the default, so you can leave it out. Limiting to 3 results will keep our context focused. Now let's handle the results. If results.length is equal to 0, we'll return no relevant information found in the knowledge base. Otherwise, we're going to format our results. So const formatted results is equal to results.map. We pass in a callback function. For each result with index, we return within square brackets index plus 1, followed by the content. And then we call .join with 2 new lines. We're basically formatting the results nicely with numbered entries separated by blank lines. We will return the formatted results. Next, we need to update our message types to include the tools. So from the AI package, import infer UI tools and UI data types. Create the new types after the tools definition. So export type chat tools is equal to infer UI tools, type of tools, and export type chat message is equal to UI message, never, since no metadata, UI data types, and chat tools. These types ensure TypeScript knows about our tools throughout the application. So update the post function to use the new message type. So messages of type chat message. Next, pass the tools to stream text. So tools, key and value being the same, so we can use the shorthand notation. And we will add a system prompt to guide the AI on when to use it. I'm going to copy paste our system prompt here. So you are a helpful assistant with access to a knowledge base. When users ask questions, search the knowledge base for relevant information. Always search before answering if the question might relate to uploaded documents. Base your answers on the search results when available. Give concise answers that correctly answer what the user is asking for. Do not flood them with all the information from the search results. That is our system prompt. It tells AI to search the knowledge base when appropriate and base its answers on the results. And one more thing. When the AI uses a tool, that's one step. Then it needs another step to process the results and respond. So we need to allow at least 2 steps. From the AI package, import step count is, and add it to stream text. Stop when step count is 2. All right, our updated route handler is complete. The AI can now search the knowledge base when answering questions. Let's test the full RAG system. First, make sure you've uploaded a PDF through the upload page. Then go to the chat interface and ask a question about the content you uploaded. For example, ask what is our vacation policy. Press enter. The AI will search the knowledge base, find relevant chunks about vacation policy, and give you an accurate answer based on your actual documents. Our vacation policy provides PTO as follows for employees with 0 to 2 years, 15, 3 to 5, 20, and the vacation request should be submitted at least 2 weeks in advance through the HR portal. We can find that information right here in the PDF. Let's ask about professional development. Are there any professional development benefits? You can see, yes, there are professional development benefits. The company invests in employees' growth by providing an annual education budget of $2,000 per employee. A RAG chatbot is working. The magic here is that the AI doesn't need to know about your documents beforehand. It searches for relevant information on demand and uses it to answer questions accurately. All right, let me now show you how to quickly implement role-based access control so only admins, such as HRs in this case, can upload knowledge documents. Right now, any authenticated user can upload PDFs to your knowledge base. Probably not what you want in a real application. We will use Clerk's metadata feature to assign roles to users and protect this upload route. First, we need to create TypeScript types for our roles. So in the application's root folder, create a new folder called types, and inside, create a file called globals.d.ts. Start by exporting an empty object. This makes the file a module. Now, let's define what roles are available in our application. So export roles is equal to admin or user. Admins can upload documents, and users can only access chat. Now, we need to extend Clerk's session token type so TypeScript knows about our roles. So declare global interface custom JWT session claims metadata role is of type roles. This extends Clerk's session claims globally. Now, when we access the user's role anywhere in our application, TypeScript will provide auto-completion and type safety. Next, let's update the middleware to protect the upload route. So open middleware.ts and at the top, import next response from next/server. We will use it to redirect non-admins. Now, create a matcher for admin-only routes. So const isAdminRoute is equal to create route matcher, and we just have the one upload route. So array with one entry upload. Next, we update the middleware function. From auth, so await auth, we get the session claims. So const session claims and check if the user's role is admin. Const isAdmin is equal to session claims, and if it exists, metadata, and if that exists, check if the role is equal to admin. If someone tries to access an admin route without being an admin, so if isAdminRoute request and the user is not an admin, we redirect them to the home page. So const URL is equal to new URL, the root route, and request.url. Return next response dot redirect to this URL. Otherwise, we continue with the normal authentication check. That's the code side done. But we still need to configure Clerk to include roles in the session token. Go to your Clerk dashboard and under the Configure tab, find the Sessions page. Scroll down and find Customize Session Token. We're going to edit this JSON, add metadata, and set it to double curly braces, user.public_metadata. This tells Clerk to include the user's public metadata in the session token. Click Save to apply the changes. Now let's set our user role as an admin. Navigate to the Users tab and select your user account. It should be the only one in the list. Scroll down to the user metadata section, and next to public, click Edit. We will set role to admin. Click Save, and our user is now an admin. Let's test it out. Back in the browser, navigate to localhost 3000/upload. We should be able to access PDF upload page. In the Clerk dashboard, switch it back to user. Save it, go back to the browser, refresh the page, and navigate to /upload. You can see we are automatically redirected to the home page. Edit, admin again, navigate to /upload, and we have access. And that's it. We've built a complete RAG chatbot from scratch. The user enters a prompt in the chat UI, which gets sent to the route handler. The route handler sends the prompt to a search tool, which does a semantic search of our vector database. It finds the relevant content, formats it, combines it with the user prompt. The AI forms a natural language response, and we stream that response back to the user. We also have authentication and role-based access control. From here, you could extend this in many ways. Support more file types, add document management features, or fine-tune the chunking strategy for better results. It is completely up to you. Thank you for watching, and if you found this video helpful, please like and subscribe for more videos on how to build AI applications.